Hello, this is our school, the Liceo Lucrezio Caro of Cittadella. We are partner in the Comenius Science Project together with Malta, France and Germany. We have decided to show you the experiment we have done in our lab. So we have chosen to study the periodic table.
We wanted to investigate the chemical properties of alkaline metals.
The alkaline metals form first group of the periodic table, that is a family of elements that show similar features.
The alkaline metals like lithium, sodium and potassium are stored under oil.
Because they are extremely reactive with oxygen and water vapor in air.
They don't look like metals.
If we cut them with a knife, they come out to be shiny and soft.
We are studying the reaction with water.
Now put some water in a beaker and add a few drops of pH indicator.
Then carefully add a little chunk of sodium.
The reaction occurring is this.
The flame means that energy has been released.
As you can see, hydrogen bubbles are pushing the chunk in water.
The color change is due to the formation of the sodium hydroxide, which is alkaline.
Let's see what happens if we use potassium.
Again, put some water in a beaker and add a few drops of a pH indicator. The reaction occurring is this.
The reactions are very similar.
But potassium is much more reactive.
If we had used rubidium, for instance, we would have caused an explosion.
Stand back, everybody, this one's going to be bad!
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone.
It seems that reactivity with water increases going down the group.
How are we sure that the released gas is hydrogen?
We collect the gas by this device.
In this way, gas bubble released during the reaction can be collected into the test tube.
Moving the test tube very carefully, let the gas meet the air, which means oxygen, and by a sparkle cause the reaction.
This noise is typical of hydrogen and proves that grey energy has been released.
And the test tube looks steamy because the reaction product is water.
Alkaline metals are so similar. How can we distinguish them?
The increased reactivity is not enough, because we can have a big explosion using a little piece of rubidium or a big piece of potassium.
It's easy if you use a spectrophotometer.
The spectrophotometer analyzes the light emitted by a source and registers a spectrum of the light.
In fact, it measures the intensity of the light as a function of its wavelength.
It is well known that every element has its own emission spectrum.
It is necessary to shield the spectrophotometer from the surrounding light.
It's better to act differently. First, put 0.008 grams of sodium in a through close to the instrument.
And then add a few drops of water.
The reaction is faster and explosive, therefore a lot of light is emitted.
This means that the order in which you put the reactants makes the difference.
Here is the spectrum. The main peak is at 590 nanometers.
What happens if we use potassium?
Here are the spectra obtained repeating the experiment with potassium.
The main peak is at 770 nanometers, different from the one of sodium.
In this way, it is possible to distinguish the elements.